do another example with an electrical conductor. Let's say that we have a hollow sphere. Okay, so we have a hollow sphere. So the sphere is electrically conducting. Okay, and so we have an electrical charge on the inside. So I'm going to call that Q1, and I'm going to put a charge of nothing onto the outside. So the outside's uncharged. Okay, so inside, we'll call this radius R1 and radius R2. So if R is less than R1, that's on the inside. What's the electric field? Well, the electric field is going to be just due to the charge inside. Whatever's happening outside doesn't matter, so the electric field will just be KQ1 over R squared. Okay, so what about R between R2 and R1? Electric field is zero. Why is the electric field zero? The electric field is zero because it's inside a conductor. But integral E dot ds is enclosed charge over epsilon naught. So what does that mean? It means the enclosed charge is zero. But there's a charge right there in the middle. There's a charge right there in the middle. How do we say the electric charge is zero? The only way that can happen is if there's a charge minus Q1 on the inside of that conductor. Okay. So this looks like it violates what we just said, but no, it doesn't, because it means the total charge on the inside is zero. But wait a minute, what's the total charge on the conductor? There was no charge of the conductor. So that means the Q on the outside of the conductor plus the Q on the inside has to equal zero. So that means there must be a charge of Q1 on the outside, spread out along the entire surface. So if you are outside here, some distance R, if you are some distance out here in which R is greater than R2, then the electric field is K sub E Q1 over R squared again, because you see a total charge of Q1 on the inside. We got Q1 minus Q1, Q1. That adds up to Q1. So that's the total enclosed charge. And so now we have three different regimes of electric field. And so we can figure this out. And so we can even find the surface charge density. The surface charge density here is going to be Q1 over 4 pi R2 squared. So remember, that's going to be equal to the charge over the volume. Or sorry, charge over the area.